Let's talk about domain and range. In this video, our objective is to find the domain and range of a function. So, when we talk about functions, remember that we have been defining them as maps or as rules that assign elements in one set to another. So, the domain of a function f taking elements in A to elements in B is the set A. So that's the formal definition, but more generally what we're talking about is it's the set of numbers allowable for that function. So it's the set of all inputs that we can actually put into f. On the other hand, the range of this same function is the set B. So in other words, it's all the obtainable numbers that we can get from f. So domain and range, when we're talking about them in practice, are sets of real numbers, and we express them in interval notation as often as we can. So let's go over some examples. Seeing is helpful in this case so that we can explore the different kinds of functions that have, for instance, restricted or completely unrestricted or very restricted domains. So for instance, the domain and range of f of x equals x cubed minus 3x squared plus 3x minus 1, which we can write, for instance, as x minus 1 cubed. Its domain is all real numbers, which remember we can write as either blackboard r or as negative infinity to infinity. And its range is the same set. Why? So this is a polynomial function. Polynomial functions are functions that have your input x in some linear combination of powers of x. So we have an x cubed, an x squared, an x, and then a constant term. There's nothing that precludes us from putting in negative numbers or irrational numbers or anything of that sort. So this is completely unrestricted. On the other hand, let's consider the function y equals 1 over x minus 3. This is a rational function. And so the domain here is if we want to make sure that everything that we can plug in here will not result in some non-allowable operation. So here we have division by some polynomial expression, which means we cannot allow x minus 3 to be equal to 0. And when that trickles down to what we actually want to say, what we're saying is we just can't let x be 3. So this is an example of where we have a domain with whole. The whole being some real number that we're not allowed to submit into this function. So our domain is all real numbers except for 3, which we can write in interval notation as the ray that goes up to 3, skips 3, and then the ray that goes from 3 out to infinity. And if we were drawing this on a real number line, we'd be saying we're covering the entire real number line except for 3. So just punch out a hole there. And as we'll see later on, these kinds of functions, this actually results in a vertical asymptote in the graph at x equals 3. So this is not necessarily a direct consequence all the time, but in this case it does result in a vertical asymptote at the vertical line x equals 3. Okay, so this is an example of a domain with hole. Similarly, we can have functions that have a restricted range. For instance, consider the function f of x equals square root of 1 minus x squared. So, first of all, the domain. What can we plug in and what can we not plug in for x? So we know that for square root functions, we can take all real numbers except for those which make the expression underneath the radical sign, the radicand, negative. So we actually would have to solve this quadratic inequality, which would lead to us concluding, and we can fill in the details if you, let me just say, pause here. I would say, solve this inequality, quadratic inequality. A hint, you may want to factor, and then check where this expression is positive and where it's not. Or you can think of this as a quadratic function and then look at the graph of the function and see where it lies above the x-axis. But what we find then is that the domain actually is the set -1 to 1, so this interval. So I'm writing it now here as in interval notation. And the range, well, what about the range? So what can we obtain from this expression? So between -1 and 1, we are plugging in values that are less than in magnitude. So the absolute value is less than 1. So we actually only get numbers that are between 0 and 1. We can get 0, and we can get 1. So brackets are on both ends of that interval. And what we're saying then is all the y values range between 0 and 1, and all the x values range between -1 and 1. And that's important because, as we'll see in the next example, what this corresponds to visually is that we may have a function where we're not given any information about the function itself, but we are also told, or given some context here. For instance, that we have 2 points here on the graph of the function, one being an endpoint and one being a lowest value. And we know that the lowest value attainable, the lowest y value that we can get is 1 over the square root of 2. So if this is y equals f of x, then we know the domain, as far as we can see here, is all the values we can obtain in the x range. So in the x range, we're looking at all the values between 0, not including 0, but up to and including 2. So this domain is 0, 2, bracket on 2. As for the range, what we're looking at now is the set of all possible y values. And since this arrow goes up forever, what this is suggesting then is that we only have a bound on what what the lowest possible y value is, which is 1 over the square root of 2, comma, all the way up to infinity. So these are the domain and range as determined from this visual representation of the function, the graph. Okay. So these come up in models. So constraints in models will frequently result in constraints on domain and range. As these come up, we'll talk about them, but just be aware that this means that our models also tells us that our functions that we're going to be using only work for certain inputs, x values, so for certain domain, and will only give us certain y values, so the range also matters here. And lastly, as a special feature of this course, some of these videos have a you try it segment, which is I'm going to pose a question or a task for you, and you will spend some time working on it. I never check. I'm not going to collect anything from you, but this is meant for you to get additional practice. So your task here for this question is to find the domain and range of this function, y equals x divided by the square root of x squared minus 9. And because we're starting out, use a graph if it helps. And the correct answers to all these videos will be posted somewhere that makes sense. I haven't decided yet, but probably on the same page in Canvas that this video corresponds to. All right, so take some time on this. This is additional practice, and so that covers more or less domain and range, but this topic, of course, comes up time and again.